Write the first 6 terms of each sequence, then graph each sequence. Part A sub 1 equals 3, a sub n equals a sub n minus 1 plus 5. You are given the first term, a sub 1 equals 3. Use the recursive equation to find the next 5 terms. A sub 2 equals a sub 1 plus 5, a sub 1 equals 3, and 3 plus 5 equals 8, so a sub 2 equals 8. A sub 3 equals a sub 2 plus 5, a sub 2 equals 8, and 8 plus 5 equals 13, so a sub 3 equals 13. A sub 4 equals a sub 3 plus 5. A sub 3 equals 13. 13 plus 5 equals 18. So a sub 4 equals 18. A sub 5 equals a sub 4 plus 5. A sub 4 equals 18. 18 plus 5 equals 23. So a sub 5 equals 23. And a sub 6 equals a sub 5 plus 6. A sub 5 equals 23. 23 plus 5 equals 28, so a sub 6 equals 28. So the first 6 terms of the sequence are 3, 8, 13, 18, 23, and 28. Now you want to graph the sequence. To graph the sequence, plot the ordered pairs 1, 3, 2, 8, 3, 13, 4, 18, 5, 23, and 6, 28. A sequence is a discrete function, so the points on the graph are not connected. Part B. A sub 1 equals 5/10. A sub n equals 2a sub n minus 1. You are given the first term, a sub 1 equals 5/10. Use the recursive equation to find the next 5 terms. A sub 2 equals 2a sub 1. A sub 1 equals 5/10, and 2 times 5/10 is 1, so a sub 2 equals 1. A sub 3 equals 2a sub 2. A sub 2 equals 1. And 2 times 1 equals 2, so a sub 3 equals 2. A sub 4 equals 2a sub 3. A sub 3 equals 2, and 2 times 2 is 4, so a sub 4 equals 4. A sub 5 equals 2a sub 4. A sub 4 equals 4, and 2 times 4 is 8, so a sub 5 equals 8. And a sub 6 equals 2a sub 5. A sub 5 equals 8, and 2 times 8 equals 16, so a sub 6 equals 16. So the first 6 terms of the sequence are 5/10, 1, 2, 4, 8, and 16. Now you want to graph the sequence. To graph the sequence, plot the ordered pairs 1, 5/10, 2, 1, 3, 2, 4, 4, 5, 8, and 6, 16. A sequence is a discrete function, so the points on the graph are not connected. Write a recursive rule for each sequence. Part A. Begin by using a table to organize the terms and find the pattern. A sub 1 is negative 8, A sub 2 is negative 1, A sub 3 is 6, A sub 4 is 13, and A sub 5 is 20. To find each term, you add 7 to the previous term. So the sequence is arithmetic with first term A sub 1 equals negative 8 and common difference D equals 7. The recursive equation for an arithmetic sequence is A sub n equals A sub n minus 1 plus D. To find the recursive equation for this sequence, substitute 7 for D. So a recursive rule for the sequence is A sub 1 equals negative 8, A sub n equals A sub n minus 1 plus 7. Part B. Again use a table to organize the terms and find a pattern. A sub 1 is 405, A sub 2 is 135, A sub 3 is 45, A sub 4 is 15, and A sub 5 is 5. To find each term, you multiply the previous term by 1/3. So the sequence is geometric with first term A sub 1 equals 405 and common ratio R equals 1/3. The recursive equation for a geometric sequence is A sub n equals R times A sub n minus 1. To find the recursive equation for this sequence, substitute 1/3 for R. So a recursive rule for the sequence is A sub 1 equals 405, A sub n equals 1/3 A sub n minus 1. Write an explicit rule for each sequence. Part A. A sub 1 equals 9, A sub n equals A sub n minus 1 minus 4. Notice that the recursive equation is of the form A sub n equals A sub n minus 1 plus D. Rewrite the equation to identify D. Here D is negative 4. So the recursive rule represents an arithmetic sequence with first term A sub 1 equals 9 and common difference D equals negative 4. The explicit rule for an arithmetic sequence is A sub n equals A sub 1 plus the quantity n minus 1 times D. Substitute 9 for A sub 1 and negative 4 for D. Distributing the negative 4 through the quantity n minus 1, you get A sub n equals 9 minus 4n plus 4. And combining like terms, you are left with A sub n equals negative 4n plus 13. So an explicit rule for the sequence is A sub n equals negative 4n plus 13. Part B. A sub 1 equals 4 5/10. A sub n equals 3 A sub n minus 1. Notice that the recursive equation is of the form A sub n equals R A sub n minus 1. A sub n equals R times A sub n minus 1, where R is 3. So the recursive rule represents a geometric sequence with first term A sub 1 equals 4 5/10 and common ratio R equals 3. The explicit rule for a geometric sequence is a sub n equals a sub 1 r to the power of the quantity n minus 1. Substitute 4 and 5/10 for a sub 1 and 3 for r. So an explicit rule for the sequence is a sub n equals 4 and 5/10 times 3 to the power of the quantity n minus 1. Write a recursive rule for each sequence. Part A sub n equals 6n minus 5. Notice that the explicit rule can be written in the form a sub n equals a sub 1 plus the quantity n minus 1 times d. Rewrite the explicit rule to identify a sub 1 and d. Here a sub 1 is 1 and d is 6. So the explicit rule represents an arithmetic sequence with first term a sub 1 equals 1 and common difference d equals 6. The recursive equation for an arithmetic sequence is a sub n equals a sub n minus 1 plus d. Substitute 6 for d. So a recursive rule for the sequence is a sub 1 equals 1, a sub n equals a sub n minus 1 plus 6. Part B. A sub n equals 4 times 3 to the power of the quantity n minus 1. Notice that the explicit rule is of the form a sub n equals a sub 1 r to the power of the quantity n minus 1. Where a sub 1 is 4 and r is 3. So the explicit rule represents a geometric sequence with first term a sub 1 equals 4 and common ratio r equals 3. The recursive equation for a geometric sequence is a sub n equals r times a sub n minus 1. Substitute 3 for r. So a recursive rule for the sequence is a sub 1 equals 4, a sub n equals 3 a sub n minus 1. Use the sequence shown. Part A. Write a recursive rule for the sequence. First, you want to find the difference between each pair of consecutive terms. Negative 37 minus negative 23 is negative 14. Negative 23 minus negative 14 is negative 9. Negative 14 minus negative 9 is negative 5. Negative 9 minus negative 5 is negative 4, and negative 5 minus negative 4 is negative 1. There is no common difference, so the sequence is not arithmetic. Now you want to find the ratio between each pair of consecutive terms. Negative 37 divided by negative 23 is 37/23. Negative 23 divided by negative 14 is 23/14. Negative 14 divided by negative 9 is 14/9. Negative 9 divided by negative 5 is 9/5. And negative 5 divided by negative 4 is 5/4. There is no common ratio, so the sequence is not geometric. Now you want to look for a pattern in the sums of consecutive terms. So find the sum of each pair of consecutive terms. A sub 1 plus a sub 2 equals negative 4 plus negative 5, which equals negative 9, which is the third term. A sub 2 plus a sub 3 equals negative 5 plus negative 9, which equals negative 14, which is the fourth term. Negative 3 plus negative 4 equals negative 14 plus negative 9, which equals negative 23, which is the fifth term. And negative 4 plus negative 5 equals negative 14 plus negative 23, which equals negative 37, which is the sixth term. So beginning with the third term, each term is the sum of the two previous terms. So a recursive rule for the sequence is a sub 1 equals negative 4, a sub 2 equals negative 5, a sub n equals a sub n minus 2 plus a sub n minus 1. Part B. Write the next three terms of the sequence. Use the recursive equation a sub n equals a sub n minus 2 plus a sub n minus 1 to find the next three terms. A sub 7 equals a sub 5 plus a sub 6. A sub 5 equals negative 23 and a sub 6 equals negative 37. Negative 23 plus negative 37 is negative 60, so a sub 7 equals negative 60. A sub 8 equals a sub 6 plus a sub 7. A sub 6 equals negative 37 and a sub 7 equals negative 60. Negative 37 plus negative 60 equals negative 97. So a sub 8 equals negative 97. A sub 9 equals a sub 7 plus a sub 8. A sub 7 equals negative 60 and a sub 8 equals negative 97. Negative 60 plus negative 97 equals negative 157. So a sub 9 equals negative 157. So the next three terms are negative 60, negative 97, and negative 157.